Hello, today we'll look at the slope of a line. And we're speaking of lines that are linear. Okay, so we're only looking at the slope of linear equations or linear lines. So, slope of linear lines. Now, when we talk about the slope, yeah, when we're talking about the slope, we're talking about the steepness of the slope. So, for example, if I look at this line here, we say that this line is not steep at all. Yeah? If I look at this line here, we say that that line is a little bit steep. If I look at this line here, this line we can say is more steep. Okay, so we want to find a way to identify what is the number that measures your steepness. Now, when we look at a line, we'll be looking at the line as we travel from the left side of the line, the left side to the right side. Okay, in our observation, here's the left side of the line, here's the right side of the line. So here we can say that this is not steep. Okay, here we can say it is a little steep. Okay, and here we can say as we travel from left to right, it is more steep as compared to the one above it. Yeah. So now slope can be a negative or a positive number. Okay, slope can be negative or positive. And the way we identify the negative or positive is based on the direction we travel. So, for example, if I look at this line, so versus this line here, yeah, we can say that the slope of this line, because this is the left, this is the right side, this slope is negative. Once again, left to right, this slope is positive. So these are all lines that we're looking at, okay? They are continuous lines. Each one of these is a continuous line. Now, what do we mean that we travel from left to right? Well, let's assume if I make believe you're here and you walk along that line, you will be going up. And because you're going up, the slope is positive. So it's very important that you travel from the left side of the line. Once again, if I'm on the left side of this line here, and you walk along that line, you will be going down. And because you go down, the slope is negative. Yeah. So you always have to travel from left to right of the line. In addition to the left or right, we can also have a line where if you walk on that line, if you walk along that line, okay, you don't go up or you don't go down as you travel from left to right. And when you don't go up or you don't go down, we say that the slope is 0. Or sometimes we say 0 slope. So basically, a summary here is that the slope of any horizontal line is 0. The slope of any horizontal line is 0. Now, we can also define slope as the ratio of the vertical change to the horizontal change. Okay? So in geometrically speaking, slope is the ratio. Okay? So slope of a line can be expressed as the ratio, and we know that ratio means fraction, okay? Ratio of the vertical change to the horizontal change. Yeah. So the vertical change, the vertical change is called the rise, yeah? And the horizontal change is called the run. So these are two terms that you will hear about when we talk about slope: rise over the run. Okay. So let's say we have a line that looks like this. Okay. So here is some line that we have. And if we want to measure the slope of this line based on a grid that we can have, so let's, if I had drawn the x-axis and the y-axis here, if we create a triangle passing through 2 points, okay, we can say here that this is the rise, this is the rise, and this is the run. So the run is the horizontal change, and the rise is the vertical change. So you will see this better if it was on a graph paper scenario, okay? But now I'm going to try to draw one where we have the numbers. So let's redraw the XY axis. And 1 unit each. And if I draw a line, it looks like that. So what you want to do is find 2 points on the line that you can clearly see the location. For example, I wouldn't pick this point here because that point is maybe 1.5 comma negative 1.5. So I wouldn't pick this. I want to pick 2 points that are clearly visible. So I would try to get them where they are whole numbers, per se, or integers. So if we look at this line, here is a point. That point seems to be 1 comma minus 2. And there are many others. I can pick this one here. This point seems to be 4 comma 1. Okay. Now, if I create a triangle, a right angle triangle, okay, so here's my triangle. This is the rise, okay. This is my rise, and this here is my run. Now the rise is the distance here. So this distance from negative 2 to positive 1 is 3 units. Okay? And the run from 1 to 4 is also 3 units. Okay? So the vertical change is 3 and the horizontal change is 3. And it's not going to always be the same number. These numbers here can be any number based on the triangle drawn. Yeah? Something to note is that no matter what points you create on the line, when you do the ratio of the two, the answer will be the same. Yeah? So it doesn't matter. Now, slope, there's a formula for slope. The formula for slope you should know. The abbreviation for slope we call m, which we have seen before. So m is equal to the rise over the run. Okay? And this is what we call the geometric form. But this, the rise, is the change in the y value. So y2 minus y1, and I would strongly recommend that you keep these things here in parentheses. Generally, you don't see the parentheses in textbooks and so on, but I'll show you why later on. x2 minus x1. So please make sure that the y always goes in the numerator and the x's goes in the denominator. Okay? So rise over run is the same as y2 minus y1 divided by x2 minus x1. And we refer to this here as the algebraic formula. Okay? The algebraic form. So we can use this here formula. We use the algebraic form when points are given to us. Okay? So can be used or to be used when 2 points are given. And we use the geometric form when we have the graph. Okay? Slash picture. So, for example, if I ask you to find the slope of the line that passes through point -2, -3, and -5, 1. So here we're given 2 points. Now we have seen before that every point consists of an x and a y. Okay? And since we have 2 of them, it doesn't matter. I'm going to call this the first point and call this the second point. It doesn't matter if I had called this the first point and called this the second point. It doesn't matter. Okay? But you have to decide. Now you're asked to find the slope and you're given 2 points. So we will use the slope formula. M is equal to y2 minus y1 divided by x2 minus x1. What I'm going to do now is wherever I see y2, I will choose the number that I've that I wrote y2 under. So that will be a 1. So as I said, keep them in parentheses because you could get confusion with the sign. For example, okay, y1, I will choose that number. And now by having the parentheses, you clearly don't get the 2 negative sign confused. Okay? Divided by x2, I will choose -5. So I will write -5 in the parentheses. And then x1, I will write -2. And that's n. Simplifying this, we have 1, these 2 negative will become positive, divided by -5, these two negative becomes positive. And this is now equal to 4 over -5 plus 2 is -3. And as we said before, generally we don't leave the negative in the denominator. We either put it on the outside or we write -4 over 3. Okay, so here our slope is a negative. So what does this mean in a picture perspective? In a picture perspective, all it means is that your line is going downward, okay, left to right, negative slope. So at least you have an idea of what the line will appears to be. You don't know the steepness, well, you do know it if you had a graph paper, okay, but you have an idea that this line, the direction that it's pointing in, okay, it's traveling downward as you travel from left to right. Now, we could have also seen this if we had a picture, okay? Because our 2 points we have was -5, 1, and -2, -3. So if we had, okay, if we had a graph, so from the graph, if I had looked at if we had plotted the 2 points, okay, -2, -3, and -5, comma 1, let's see what happened. So -2, -3 will be this point here. Okay, this is -2, -3, and -5, comma 1, -5, comma 1 will be here. Okay, and if I connect those two points, connect a line passing through those 2 points. Okay, and let us create a triangle. Now, notice that I can create a triangle this way. And you will see that the rise here, okay, the rise we got as 4 units, 4. And the run we have 3. But because the slope is, or the line is traveling from left to right, okay, we can say the run is -3 because you travel from left to right, okay? Or generally what I do, I don't look at the sign of the numbers here. So we can say that the slope m, the rise over the run, is equal to 4 over 3, But then if you look at the line is moving downward, okay, downward from left to right. So I know that the answer is negative. And the reason I don't like putting the negative here is because we generally say that because this is a measurement of the distance, right? How many units you travel. We can't have a negative distance. But if you feel comfortable doing that, because this is just a working for you to get your work correctly, you can think of it that way. So no matter if you get the graph or the point, clearly the graph can give you some errors if the points are not integer numbers. Okay. How about this one here? Okay, so let's look at another example. Find the slope of the line containing the point 3 comma minus 1 and 3 comma 4. Okay, so we'll first use the formula. We will use the formula and then look at it graphically. So we have 2 points. So this is x and y. So I'll call this x1, y1, x2, y2. So we know that the formula m is equal to y2 minus y1 divided by x2 minus x1. And what I'm going to do now is plug in those values that I have associated them with. For example, y2 would be 4. Okay, so this is a 4. My y1 is negative 1. My x2 is 3, right? My x2 is 3, okay? And my x1 is also 3. So here we have m is equal to, these two negative becomes positive, 4 plus 1 over 3 minus 3, and that is equal to 5 over 0. And we know that anything over 0 is what we call undefined. Undefined. Now, observed with the 2 points, yes, the 2 points given are 3 comma minus 1 and 3 comma 4. And please note that the x value were the same. So when you subtract them, you would have got a 0 in the denominator. Okay. So what does this mean that it's undefined? What does the line look like? Well, let's plot the points. Okay. So let's plot points to see the line. And if we do this, we have 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4. The first point, x is 3, y is 4. So that will be this point here. And then the second point is x is 3, y is -1. That's this point here. And if you connect those 2 points, the line passing through those 2 points, you see you have what is a vertical line. And there is no way to tell the steepness of a vertical line. So M is undefined. And this will be the case in every single situation. Okay? Every situation. So you will note the slope of any vertical line is undefined. And we also established earlier, which we will show, the slope of any horizontal line is 0. Because if the line is horizontal, there is no steepness to that line. Okay? There is no steepness. We cannot measure the rise over the run. So let's look at that. Example, find the slope of the line passing through the points 2, -3 and 4, -3. Okay. So we will use the formula since we have the slope here. So let's call this x1, y1, x2, y2. Yeah. And we'll use our formula. M is equal to y2 minus y1 divided by x2 minus x1. And if I plug in those numbers associated with my x's and y's, so instead of y2, I'm going to write -3. Instead of y1, -3. Instead of x2, 4. And instead of x1, 2. Simplifying this becomes -3. The 2 negative becomes plus. And then we have 4 minus 2 in the denominator. So we have m is 0 over 2. Therefore, m is equal to 0. So notice that in this case, 0 is in the numerator. Okay? And notice on my point now, the y values were the same as before in my last example. The x values are the same. So when the y values are the same, automatically you should know that this line has a 0 slope. Now, if you plot these points, if we look at this graphically, okay, the given points were 2 minus 3 and 4 minus 3. see if you plot these 2 points, connect a line passing through them, we will be able to see if that line is a horizontal line. So the first point I want to plot is 4, -3, which is there, and then 2, -3, which is here. And if I connect a line passing through those points, you will see that this line is a horizontal line. Therefore, m is equal to 0. So the slope of any horizontal line, okay, any horizontal line, slope, horizontal, 0. Slope of any vertical line is undefined. Okay? And we did this algebraically or geometrically by the picture. Now, we will have cases, okay, where if you look at a picture, okay, if we look at a picture, if I have 2 lines, so let's call this line 1, and if I have a second line, let's try that again. Okay, let's call this line 2. Now these lines appear to be parallel, okay, parallel lines, parallel, and we will see that when lines are parallel, okay, parallel lines, we can say that L1, line 1, and L2 has the same slope. Okay? So anytime lines are parallel, the slopes are the same. Okay? Now, what happens if they are not parallel and let's say they are perpendicular? Well, remember what perpendicular is, right? Perpendicular mean that they cross at 90 degrees. So let's say I have this line here, let's call this line 1, and let's say I have another line when they cross, let's say line 2, when this angle here is 90 degree, okay, when the angle is 90 degree, they are perpendicular. And when the lines are perpendicular, here we will say that L1, okay, or L2, L1 and L2 are perpendicular. And this means that the slope, okay, M for line 1 is the negative reciprocal of the slope of line 2. Okay. Let's just make sure we have the notation correct. So line 1 slope is positive. So I need to change that. Okay. So L2 is going to be the negative reciprocal of M of line 2. Line 1, sorry. So what does that mean? It means, first of all, if, so let's look at an example. If two lines are perpendicular, and one of them has a slope of 3, then the second line will have a slope of what? Okay. Now you notice here that these lines are perpendicular. So if one of the line, let's say line 1 is equal to the slope, let's write it out, the slope of line 1 is equal to 3. Therefore, the slope of line 2 must be the opposite, negative, and the reciprocal of 3, which is 1 over 3. Okay? Negative 1 over 3. We flip it, because this is the same as 3 over 1, right? Reciprocal just means flip. So this answer here will be negative 1/3. Notice that when lines are perpendicular, okay, that the signs of the slope are always opposite. One is positive and one is negative. In addition, for your notes, if you find the product of the slopes of perpendicular line, the product will always be -1. The product of the slopes, if you multiply the slopes of any two lines that are perpendicular, it will always be -1. Always. So let's look at an example or two examples. Example, find the slope of any line that is parallel to the line that passes through points 2, 3 and -8, 1. Okay, so we're looking for the slope of any line that is parallel that passes through these 2 points. So first, let's find the slope of the line with those 2 points. So the slope of the line passing through points 2, 3 and -8, 1. That's the first thing. So as we did before, x1, y1, x2, y2. And we know the formula m is equal to y2 minus y1 divided by x2 minus x1. Now we'll plug in the numbers. So m is equal to, instead of y2, I'm going to write 1. Instead of y1, I will write 3. Divided by, instead of x2, I will write -8. And instead of x1, I'm going to write 2. So m is equal to 1 minus 3 is -2. Okay. Divided by -8 minus 2 is -10. And this can be simplified. 2 negatives, when you divide, will become positive. 2 over 10. And then also I can simplify by dividing top and bottom by 2. So this becomes 1/5. So the slope of the line that passes through those 2 points is 1/5. Therefore, 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 the slope of any parallel line is also 1 divided by 5th. And that's what they're asking you to find. They're asking you to find the slope of any line that is parallel to the given line. So your answer is not just m equals 1/5. The slope of any parallel line is also 1/5. Okay? Example, how about if we change that? Find the slope of perpendicular now. So let's say a line contains the points 3, 4 and -3, 1. Find the slope of a perpendicular line. Okay, to the line passes through points. So now you want to find the slope of the perpendicular line. So before you do that, what we're going to do, we must first find the slope of the line passing through 3, 4 and minus 3, 1. So let's identify x1, y1, x2, y2, and we know that the formula is y2 minus y1 divided by x2 minus x1. So this becomes m is equal to y2 minus y1 over x2. So instead of y2, I have a 1. Instead of y1, I have a 4. Instead of x2, I have a minus 3. And instead of x1, I have 3. So therefore, m is equal to 1 minus 4 is negative 3. And minus 3 minus 3 is minus 6. Therefore, m is equal to 3 over 6. And if I divide top and bottom by 3 now, we get 1 over 3. So note, this is the slope. This is the slope for the line passing through the given points. Okay? But for the perpendicular line, m will be equal to negative, okay, times the reciprocal, so 1 over 3 becomes 3 over 1. And that becomes negative 3. Okay? So the answer, m is equal to negative 3. This is the perpendicular line slope. Okay? Notice, as I said before, 1 is negative, okay, and 1 is positive. And this will always be the case for perpendicular lines. So what we're going to do next is, now that we know how to find the slope, we're going to start looking at finding the equations of these lines. Okay? So we look how to plot the line, we saw how to graph lines, we now saw how to find the slope, we've seen how to find the y-intercepts, and my next video I will show you how to get the equation of lines given some information. Okay? So see you in my next video.